Good evening, all. We have learned how to draw a beam layout in the previous class. So today we will see how the column layout is prepared so that we can complete a preliminary beam column layout, and we can submit that to for a, approval from the architect. So Neha, you can start the presentation.
Is my screen visible?
Yes, it is
Hello.
visible.
Okay. Okay. Uh, Now we can see where can we place a column correctly in an architectural drawing. So first of all, we need to study the architectural drawing which is given to us. Now I have already drawn the beam layout, which you have already learned in the last class. And if you see this drawing, there are two architectural plans given. That is the ground floor plan, and the second one is the first floor plan. So this is a G+1 building. That is, this is the ground plus one. That is the first floor building. That is the G+1 building. So we need to place the column correctly in position. So in the last class, you have learned that the spacing between the columns should be from 4 to 5 meters. That is, the interval should be limited to 4 to 5 meters. The spacing between the columns should be 4 to 5 meters. So first, we need to identify where we can place a column correctly. So before that, I will show you how to draw a column. So normally this is a villa project. So normally we will be starting from 200 by 300. That is 20 by 30 size column or 20 by 40 sized column. So I will be drawing a 20 by 40 column here. So this is the 20 by 40 column, that is 200 mm by 400 mm sized column. So this is just a rectangle. We cannot identify it easily. So we will be adding some features, extra unique features to this rectangle so that we can identify that it is a column. So for that, we will be adding a hatch to the column. So the hatch uses ANS I137. So this is a solid hatch. We can change its property. We can scale it. So we can change its color too. So for this hatch we will be providing red color, and for this outer layer we will be providing yellow color. So this color variation or this specification will change or will be different uh, for different companies. So here we will be using this color, that is red color for the hatch and yellow color for the outer line in this company. So this is the column. So next we need to identify the places where we can keep the column in the right position. So the first and foremost thing, we can keep the column or we can place the column at all the four corners of a building. So we can place a column at corners of a building. So if you look, we can place a column here, at this corner, and at this corner too. So there is a wall provided here. So we can place a column at this portion too, because when we look into the first floor plan, there is a bedroom at the top level of this portion. So we need to transfer that bedroom load to the ground floor. So we should place a column here too. So I will show you how to place a column. So we have already identified that we can place column at the corners. So we can place a column here at the first corner, here at the second corner, here too, here, and here. So I have already placed the column at the four corners of a building given plan. I have placed it correctly. So next we need to identify where can we place the remaining columns. So I have already said the distance between the columns should be 4 to 5 meters. It should be limited to 4 to 5 meters. So considering this wall, we can measure the distance between the column. If we measure the distance, it's almost 9.2 meters, isn't it? So we should limit that to 4 to 5 meter. So we need to provide a column at this portion so that we can reduce the distance between the column. So at this portion, we need to have a column. So we can just try like we can provide a column at this portion. So when we provide a column here at this portion, this column is not visible when we stand inside this room because this column is aligned with this column is within the wall. There is a wall here. So this column is within this wall so that we cannot see this column in the bedroom or in the toilet. This wall will be closing this column inside it. So that's okay. We can place a column here. Now it's okay for the ground floor plan. We can place a column here. It's okay. This column is not visible in the bedroom and the toilet. It's okay for the ground floor plan. So this, as you all know, this column will be starting from the base, that is the foundation, and it will be extending up to the terrace floor. So we need to look how this column will be at the first floor too. So we have placed a column in the ground floor, which is okay. But we need to look the architectural drawing of the first floor too in order to finalize the position. So, so for that, we will be copying this column with the base point and we will be pasting it to the first floor plan. So I have pasted that column at the right position in the first floor. So when you see, when we look into this, we can see that this column is projected outside. That is, when we enter this room, we can see this column. This column is not encased in the wall. So we can look why is that? Because we can look the length of the room. It's 3.72 meters. And in the ground floor, the length is 3.52 meters. So that's the reason why this column has projected outside. It's 3.52 in the ground floor and 3.72 in the first floor. So that's the reason why the column has projected outside and we can see that column when we enter the room. So that idea of providing column at this portion was not okay. That was bad and we cannot provide a column like that because that column will be passing through the bedroom when it comes to the first floor. So next, let's try to add a column or keep a column here. So when we place a column here and when we look into the first floor plan, there is no wall at this portion. There is no wall at this portion. So when we place a column here, that column will be projected at this portion in the first floor. So I will show you. So when we place a column at this portion, and we can copy with base and paste it to the first floor, that column will be passing through this room, isn't it? That column will be passing through this room, and so that we cannot place a column here too. So that both idea of placing column in this direction is not okay. So now let's find how can we place a column. We need a column here. So we need to place a column here. So we will be rotating that column and we will be trying. So we will be rotating that column 90 degrees. We will be changing the orientation. So now I have placed a column in this direction. And now let's check how it's in the first floor. When we place a column in the ground floor, we need to check how it passes through the first floor too. So I have oriented this column in this direction and I have pasted in the first floor. So when we look into this column this beam is not passing fully through this column. This beam has this beam does not have full connection to this column. Only half portion of the beam is passing through this column. So we should try whether we can make this beam to completely pass through this column. So we will be shifting the position of this column of this both the column, and I have shifted this little bit to the right. And here when we consider the ground floor, the beam is directly entering into this column, and now when we consider the first floor, this beam is directly entering into the column. So if we look into it, this column at the left portion has a complete connection to the beam at the ground floor, and this column at the right portion has a complete connection to the beam at the first floor. So that idea of providing column at this is okay. This portion, this place is okay because the column has a beam connection at this both the portion, and the direction is also safe. So we have completed this level where there is 3 columns and the distance is less than 5 meters. So now let's look at this next wall. So now let's measure the dimension of that wall. It's almost 9.2 meters. So here also we need 3 columns in order to make the building safe. So we have already provided 2 columns at the either ends of the building. So we need to provide a column at the center portion. So when we look into this portion, there is a window here. So we cannot provide a column through a window. And so for that, we need to find a place where this column can be placed. So we need to find a wall so that we can place a column. So when we look here, there is a wall portion here so that we can place a column here. And I will be copying a column from here, this column, and I will be pasting. So I have pasted a column at this portion and it's okay in the ground floor. Now the next step is to check whether it's okay for the first floor. So for that, I will be copying this column from the base point, clicking the base point, and I will be pasting it. Okay, copied it, mistake. Uh, I'll be copying and I have pasted it here. So when we look into the first floor plan, this column is passing through this ventilation. So we cannot provide that here because in the ground floor, this was okay. This was at the wall side. The column was at the wall side. But when it came to the first floor, it passed through the ventilation. So which is not okay. So we will be trying, so this column cannot, we will be trying shifting the column so that it's we can make it correct. But here this column cannot be shifted upwards in the ground floor because there is a window here, and in the first floor we cannot shift it downwards because there is a ventilation here. Also there is a window at the bottom portion, so we cannot shift this column, but we need a column here. So for that, what we will do, the same thing that we have done here, we will be changing the orientation of the column. So we can change the orientation of that column and we can paste here. So after pasting here, we can check whether this is okay for ground floor. We can check whether this column position is okay for the first floor too. So for that, we will be copying it from the first floor, the ground floor, and pasting it into the first floor. So, okay, the positioning was not wrong. Okay. Now, the column position is right, like it's aligning the wall in the ground and it's also in the right position in the first. So this positioning of the column was right. So I have provided a column here. Now, actually this column was supposed to be here at the mid portion, but I have provided it here because at the mid portion there was a window. So now let's check the distance of this column to column. And if we look into that, it's almost 6 meters. For safety, we will be, because as I said, the distance between the columns should be 4 to 5 meters. So for safety, we will be providing a column at this portion too. So I'll be providing a column at this portion. I'll be copying it from here and pasting it here. So this is okay for the ground floor. The next step is to check whether it's okay for the second floor too, first floor too. So I will be copying this with a base point. And after that, I will be pasting here. So if we look into it, it's slightly coinciding with the ventilation. So we can try another idea, or we can try shifting the column. So we can shift this column little bit downwards. We can check. Okay, we can shift this column little bit downwards. Okay, now we can check whether, okay, now it's not coinciding. Okay, so like this, we need to shift the column and try whether it's okay, whether both the first and ground floor, whether the column is safe for both the first and the ground floor. So here I have shifted the column a little bit so that the column is fully inside the wall and it is not coinciding with the ventilation. So this side is also completed. So this side and this side is completed. So now let's look on to this next portion. I have already placed a column. Okay, here we have already placed 3 columns at the corners. First corner, second corner, and the third corner. That is here, it's a parking, and this is the corner of the building of the ground floor. So we have also placed a column here too. So now let's check whether we need a column at this portion. We need to check the center to center distance. We need to check the distance. It's almost 6.5 meters. So we need a column in between these two. So we will be providing a column here too. So we will be copying a column and we will be pasting a column here. Okay. Now we can check. We can check whether it is okay for the first floor too. We will be copying from the base point. So I have pasted this column here. So now when we look into it, this is an open terrace in the first floor. And this column, if this column is placed at this position, this will be like this in the first floor. And that small portion will be projected in the open terrace space. So we need to shift that column so that it is not visible in the first floor. So we need to move that like it is not visible in the first floor. We will be moving down. We will be shifting it little bit down. And yeah, it's okay now. It's okay for the first floor. Now we can check whether it's okay for the ground floor. Yes, it's okay for the ground floor. The column is within the wall so that it is not visible in either the first floor or the second floor, ground floor. Okay. So we have completed this side too. We have completed the first horizontal side and both the vertical side. Now we can look into this side and as I said, here we need 3 columns. So the dimension of here is also same. So here also we need a 3 column at the center portion. And here, if we provide a column at the center portion, this is sit out. So we will not provide a column at the sit out, isn't it? We will be providing a column at the wall. So here, the wall, I will be showing you architecture. So, okay, this is the architectural drawing without beam. And this is the architectural drawing without beam. And we can provide a column at this wall portion because we cannot provide a column at the sit out. Here is a main door and we cannot provide a column here because this is a car parking area. So we will be providing a column at the wall portion. So we can provide a column here at the wall portion. So we can copy a column, 20 by 40 column, and we can paste at the ground floor. Okay. Okay, I have pasted a column. I have placed a column at this portion. And now we can check whether the column which I have placed in the ground floor is okay for the first floor too. So for that, I will be copying with the base point. I'll be pasting here. Okay. Now, if we look into this, here it's a cutout. It's a seen below portion and there is no wall here too. It's just a architectural it's just an architectural portion. There is no wall. Okay, if you see the 3D of this picture, there is no wall under this square portion. In this square portion, there is no wall. So we cannot keep a column here because there is no wall below it. So we need to shift this column little bit left. So we will be shifting that column. I don't have that 3D image to show. So that's why. Okay, I will be shifting this column to little bit left side. So now it's okay. Okay, I have provided column here too. So after that, when we look into this portion, here there are this is the main beam and there are beams coming to it. So this beam will become heavy and there will be chance of deflection and failure. So we need to provide a column at this portion too, because this is a long beam without column connection. This beam doesn't have a column connection. This is a beam without column connection, without support. And also there are beams coming to it, entering. This is the main beam and there are beams entering it. So this beam will become heavy and chances of deflection are higher and failure will be happening. So for that, we should provide a column at this portion too. So we will be looking at the ground floor. This is the parking area. We cannot provide a column here. This is a sit out. We cannot provide a column here. And we should find a wall so that we can provide a column. So here there is a wall. There is a small wall here. So we can provide a column here. And let's check after that. Let's check whether it's okay for the first floor too. So I'll be copying a column. And I'll be placing it here. So now let's check whether this is okay for the first floor too. So I will be copying from the base point and I'll be placing it. So if we look into this, I have placed this column at this portion. And when it came to the first floor, the column has projected in this bedroom. That is the study area. This is a bedroom and this column has projected into this room. So which is not okay. When we enter this room, we can see the column outside, projecting outside the wall. So to avoid that, we can shift this column. Another option is to shift this column towards bottom. And here also we need to shift this column towards the bottom. You can shift this towards the bottom. And after that, we can check whether it's okay for the first floor, but now we can check whether it's okay for the ground floor too. So here there is a projection. There is no wall here. There is no wall here, but there is a projection of column here. One option is to reduce the size of the column and make the column 20 by 20. That is 200 by 200 size column. That is the one option to provide. And second option, we can just provide the same size same size of the column here and ask the architect whether it's okay for that. Okay for them. Just we can speak with the architect and ask them whether this column or this projection at the sit out level is okay for them. That's the that these are the two options that we can provide. Okay, now this portion is okay. And let's look on to this portion. Here we have provided now columns. So we need to provide column at this portion too. So now let's check this level. So at this level, this center to center distance between column is 9 meters. So we need to provide a column here. And we need to find a wall so that we can provide a column. Here the wall is this at the ground floor. And we can provide a column at this portion. So we can copy the column and okay. So I have provided a column at inside this wall. And now let's check whether this column position is okay with the first floor. So I'll be copying with the base point and I'll be placing here. So this column has came here. I have provided this column here, but this column came here. When you look into this, you can see it's a door. So if we provide a column at this portion, at the first floor level, it will be coming to the door, isn't it? It will be passing inside the door. So which is not okay. The column will be passing inside the door, which is not okay. So that providing column at this portion is idea of providing column at this portion is not safe. So let's try to shift this column. And if we shift this column towards right, in the ground floor, it will be coming in the parking area, isn't it? The projection will be coming in the parking area. And if we shift this column to the left, it will be coming in the living room in the ground floor. So we cannot shift this column towards right or towards left. If we shift it to the left side, it will be coming at the living room. So when we enter through this main door, we can see a column at this living room. So if we shift this column towards right, it will be coming at the parking area. So we cannot provide a column here. So let's try to find another way so that we can balance, so we can reduce the 9-meter distance. Another idea is to provide a column at this portion. We can provide a column at this portion, but when we look into it, providing a column at this portion makes this distance smaller, but from this column to this column, the distance will be more. So providing that column at that portion is also not a good idea, but we need a column here too. So we can do one idea. One idea is to start the column from the ground floor and terminate it at the first floor. That is, we can start a column from the ground floor and this column will be only up to the first floor level. It will be ending at the first floor level and it will not be rising from the first floor. This column will be up to this level from the ground floor till the first floor. It will be up to this level so that it will not be passing through this door. So we can provide a column here, and to make it identify, we can give a name to this column. That is, we can provide name TC, that is the terminating column. We can provide a name TC for this column, that is terminating, which indicates that this column will be starting from the below level and ending in this first floor level. So that problem was okay. We have solved that problem and the spacing in the ground floor. So when we look into the first floor, this column will be terminating at this portion. So there is no other columns at this portion. So we need to provide columns in this first floor level too. So we will be starting a floating column from the first floor. So when we look into this wall, this is this wall size is less. It's not a 20 thick wall. It's just 149. That is, it's a 15 thick wall and this is a 10 thick wall. So we cannot start a column from this wall because if we start a column from this wall, this column size will be projecting inside the room. So we need to start a column at this portion. So when we start a column from a beam from another level, it's called floating column. So we will be starting a floating column from here. So if a column is started from the ground floor and ended in the first floor, it is known as terminating column. And if a column is started in the first floor, that is from the beam, and it is known as floating column. So we can provide a floating column here to support the above beams. So we can rotate it. We cannot provide that column in this direction. We can change its orientation and we can place it here. Okay. We can place it at this portion. Okay. Okay. Now this is also fine. So we have provided columns at this portion, this, and this. So only portion left is the top portion. So now let's look onto that portion. So here we need columns. So first we need to find a wall so that we can place a column. So at the center portion, if okay, this wall is fine. Okay, this wall is fine, and we can provide a column at this portion. We can take a column, take a copy of it, and provide it at this column. So this is the ground floor level. So now we need to check whether it's okay for the first floor too. So take a copy, picking from the base, pasting it with the base. So it was okay for the first ground floor. When it come to the first floor, this column was like this. That is, there is no wall in this area. I'll show you the direct architecture plan. So there is no walls in this area. This is an upper living room. So when I started a column at this portion, the column passed through this portion at the center portion of the room where there is no wall. So we can see that column is passing through this room. So which is not okay, because we can see a column which is unnecessarily passing through the upper living area. So we cannot provide a column like that. So idea of providing column here was not okay. We can delete that column and we can find another way. So another way we can look here, there is a wall. So we can try keeping a column there. So we can copy a column here and we can keep it here. Now we can check whether it's okay for the first floor. Okay. When it come to the first floor, this column was like this. It's a 10 thick wall, and this column, when it comes to the first floor, it was like this. There is also a door which is coming here. This wall is also 10 thick, and this orientation is vertical. So the column will be going like this, which is not okay. So we cannot provide a column like this, continuous column like this. So we can find another way so that we can place a column at any other portion. So we can try keeping a column here. We can look whether we can keep a column here. So we'll be copying a column from this portion. We will be copying a column and we will be pasting this column at the portion. And we will be checking whether it's okay for the first floor. And I have pasted here. Yeah, it's okay for the first floor. The ground floor and the first floor, both the floors, the column is passing through the wall, which is not so that the column is not visible outside, and it's okay. So providing column there was also fine. Here there was a problem because when I place the column here, when it comes to the first floor, the column like this, which is projecting outside all the portion. But so I'll be deleting this column. Okay. So we cannot provide a column here. So, but when we look into this portion, we can see in our beam column in the beam layout, there are lots and lots of beam at or crowded at this area, isn't it? This beam is coming, this beam is coming, this and this. There is a lot of crowded area in this portion. So there we need a column. That's a must because all these beams are coming. There is no portion for load transfer because at this junction there is lots and lots of beam coming. So we need to provide a column there. That's a must. So we will be providing a column there. We need a column there. But if we provide a column like this, that will be coming like this. And we have no other option rather than providing a column. So we will be finding an idea so that it will not be architecturally affecting the beam column layout, architecturally affecting the plan. So this column, it's okay. It's okay for this column. That is, it's okay for this ground column which I have placed in the ground to move past like this because it's inside the wall. It's inside the wall, and this column is safe in the ground floor, which is not visible. It's also not visible in the ground floor. But when it comes to the first floor, it is visible. So we can do one thing. We can start a column from the ground floor and terminate the same column at the ground floor. We can make this column as terminating column. And we can start a column from here too. So we can start a horizontal column. We cannot provide this column in this vertical direction as there is a door coming. Also this much projection will be there, isn't it? This much projection will be there. So another idea is to provide a column, floating column at that portion. So we can provide a floating column like this. And we can reduce its size. It's a 20 by 40 column. We can reduce it to 20 by 30 or something. Because there are too many beams coming. So this column is a necessary or it's must that there should be there because this load should be transferred to the ground floor. So there should be a column. So we will be providing a column like this. We will be providing a floating column like this. So this column will be starting from here in this vertical orientation, coming till here in this vertical orientation at the first floor, and it will be terminated at the first floor, and we will be starting a floating column at the same level and it will be raised till the terrace floor. So here when we look, it's a 10 mm thick wall, but this column is 20. This is a 10 mm thick wall and sorry 10 centimeter thick wall, and this is a 20 centimeter thick column. There will be projection, but we have no other option rather to provide this. We have no other option than providing this because we need a column there. That is a must. So we will be providing this and we will be trying to make it safe using ETABS model. So this is the beam column layout. So we have placed the beam and we have drawn the beam and also placed the column. So this portion is the preliminary BC layout. This is the preliminary beam column layout. Okay, this is the preliminary beam column layout that we prepare. So before finalizing this preliminary beam column layout, first we will be superimposing like this. We will be superimposing this beam to the architectural plan and column 2 to the architectural plan, and we will be sending it to the architect or the client for the approval. So we can also make some comments. So if we look into this, suppose if we need the column at this portion, but there is a door at this portion. So there is no, suppose there is no another way than providing column here, but there is a door here. So we can recommend the architect, or we can ask the architect to shift the door at the towards the left. We can ask for suggestions. We can ask. We can also recommend them to shift the door. So here I have said that starting a column through the window is not possible. I needed a column here, but there was a window there. So I am not possible to provide a column there because of window. So I can ask the architect to shift the position of the window. I can ask them and I can get confirmation. If he approves, I can start a column here. If he is willing to change the window, I can provide a column here. So before doing any changes in the architectural drawing, we need to ask for the approval from the architect side. We can provide recommendations, we can provide comments for them, like shifting the door and all. We can provide comments for them, but if they are approving, we can do or move forward with the same. But if they're not approving, we need to find another suitable way so that the framing is okay. So after this preparation of beam column layout, we will be sending this to the architect or the client for the approval. So after getting the approval from the client, they need to check whether they can provide a column there, whether it affects the architectural beauty, whether it's okay for them, like that. So we need a confirmation from their side. These are the columns which we have provided. So we need a confirmation from the client also, so that we can finalize this column positioning. So after that, when we get the approval, we will be importing this beam column layout to ETABS. And after that, we will be applying all the loads to this beam column layout framing, and we will be analyzing. So after analyzing, there will be changes in the column positioning because there will be failures. When we analyze in the ETABS, there will be failures, there will be column failure or there will be beam failure. So we should increase the size of the column. We should increase the size of the beam, all at that time. We will be changing after analyzing. So this is not the final size. This is not the final size of the column. This is not the final size for the beam. We will be finalizing it only after analyzing and making the model safe in the ETABS. So that's how a beam column layout is prepared and a structural beam column layout is finalized. Final beam column layout will be finalized only after analyzing and only after getting approval from the client. So that's all about the beam column layout preparation. So I have completed the column layout positioning. I think you have understood. Anyone have any doubts?